Now this is our second lesson on algebraic expression, and now we are on factorization. Now in this tutorials we'll be considering that is the common monomial factor. That is, if you have AB plus AC, there's a monomial factor. So here are A, we can bring the A out and you have A, B plus C. So we'll be considering this type, that will be the first thing, and then we'll continue with factorization of the quadratic expression, and then we'll continue with, that is the difference of two squares, and this will consider expressions like ax squared plus bx plus c, where the a is not equal to 0. We'll consider difference of two squares, that is, if you have a squared minus b squared, we'll consider that, and then also we'll consider sum and difference of two cubes. That is, if you have a cube plus b cube, how do we factorize? And then also if you have a cube minus b cube, this the sum of two cubes, and then this is the difference of two cubes. So basically this is what we are going to do on this tutorial. Make sure that you watch everything. There'll be a whole lot of things that you learn that will help you in mathematics. Now in our first one, we'll consider the common monomial factor. Now that is, if you have AB plus AC, here we can see that A and A is a factor of the AB, AC is a factor, A is a factor of the AC. So here we can bring the factor out and have B plus C. And when we apply the distributive law, we are going to get, that is AB, and then we get AC. Now let's see example. So we have factorized each of the following. The first one, we have 5p plus pt. Clearly p is a factor of the 5p, and then we have pt, so p is a factor. So the common, we bring it out, and then we have 5 plus t. So here p is common, we bring the p out. Now let's see the second one. We have 2x plus 4. Here 2 is common, so we can bring 2 out and we have x plus 2, because the 4 we can express the 4 as 2 times 2, and we can bring that common factor out. Now let's see the third one. We have 3m minus 6. Now 6, we can express 6 as 6, that is 3 times 2, so the common will be 3. We bring the 3 out and we are going to get m minus 2, so 3 times 2, that's giving us the negative 6. Now let's see the fourth one. So this is the first one, second, third, fourth one. We have 5 minus 10m. Now we can express this 10 as 5 times 2. So there's 5 here, there's 5 here. We can bring the 5 out, and we are going to get 1 minus 2m. Why? This is 5 times 1. So we can bring the 5 out. 5 times 2, we can bring the 5 out. Now let's see the fifth one. We have 4x squared plus 4. Here clearly there's 4 here, there's 4 there, so we can bring the 4 out. When we bring the 4 out, what is left here? We have x squared and plus 1. So here 4 times x squared, this is giving us 4x squared. 4 times 1, we have 4. Now let's see the sixth one. We have 4m plus 12. So 4m plus 12. Now let's see, we can express this 12 as 4 times 3. So we have 4, we can bring the 4 out, and you get m plus 3. So 4 times 3 giving us the 12. Let's consider the next example. Now let's consider this example. Factorize each of the following. Now the first one, we have ax squared plus bx squared. Here x squared is common, so we can bring the x squared out, and we have a plus b. So this time this, we have x squared times a, we have ax squared, x squared times b, we have bx squared, because x squared is common. Now the second one, we have a squared minus ab. Now a squared can be expressed as a times a minus a times b. Now here you can see that a and a is common. So you have a here, common, we can bring it out, and then we have a minus b. Because if we have ab plus ac, the common one is a, so bring the a out. B plus c. Here the common one is e. Just bring it out. Now let's see the third one, n squared minus 7n. And let's say we can express this as n times n. And because it's multiple, we have n2 here. We can bring the n out, and we have n minus 7. Now the fourth one, we have x squared plus x. Now x squared plus x is common here, so we bring x out, and then we have x plus 1. Now let's see the fifth one, we have 3e squared plus 5e. Now in this case, the e is common, we bring the e out. So e out, and we have 3e plus 5. So this time that's 3e squared. E times 5, that is 5e. Now let's consider this example. Factorize each of the following. We have our first one, 2x squared minus 4xy. Now in this question, let's see, we can express this as 2x times x. We can also get 2 times 2x over here. So 2x is common. We can factorize 2x out. So you can bring 2x out. And then what do you think will be left here? We have x squared, so we have only x here minus 2y. Now let's multiply to 2x times x, that is 2x squared. 2x times 2y, that is 4xy. Now let's see the second one. We have 3p squared minus 6pq. Now with this, the common factor, we know that we can get 3p here. We can also get 3p here. So we get 3p out, and we are going to get p minus 2q. This time this will give us that. Now the third one, we have 20p plus 25p squared is equal to, now let's see, 5 is a factor of 20p, 5 is a factor of 25, and we can see p also here, so we can get p here, we can also get p here. So it's telling us that 5p is a common factor. So 5p, common factor out, and we are going to get 4 plus 5p. So 5 times 5, 25, p times p, that is p squared. Now let's see the fourth one. The fourth one, we have 9m squared minus 18m. And in this, we can see that 9 is a factor of 18. We can express 18 as a 9 times 2. We have m here, so 9m is a common factor. So 9m out. Now this m squared, so m will be left out here, and then minus 2. So this time this will give us this time this, we have that. Now let's see the fifth one. We have 6x squared plus 6x. Now, so 6 is a common factor, and we can also see x is also a common factor. So 6x out, and we have x plus 1. Now 6x times x, that's 6x squared, 6x times 1, that is 6x. Now let's see the sixth one. The sixth one, we have 15c squared minus 5c. Now, so clearly 5 is a factor of this. We can also see 5 is also a factor of that. C is common, so we have 5c out. We can get 3c minus 1. And yeah, so that is that. Now let's see this example. So factor the following. The first one, we have 8a squared plus 12a. Now here, clearly a and a, we have a squared here, a, so we can get a out. Now 8 and then 12, so clearly we can get 4 as a common factor out. So we have 4a out. Now 4 times 4 will give us 8. That will be 2a, and then 4 times 3. So we factorize it. Now let's see the second one. We have 2a squared b plus 6ab squared. Now clearly 2 is a factor here, and then we can also get 2 as a factor from the 6. So the common one, 2, go out. Now we can also have AB being the factor of this, AB being the factor of this. So we can bring 2ab out. Now this is a square. It means that a, it will be remaining a inside the b, and when you multiply you're going to get this. Now this we have 6 and we've taken 2 out, so we will get 3. 2 times 3 giving us the 6. Now we have b squared, we have b here, so we have to bring b over there. Now let's see the third one. The third one, we have 5a squared b plus ab squared. Now with this, what can we see? We can clearly see that here the common factor a is common. We can bring the a out, so ab is common. Now but then I have a here, so I have 5a because of the square, 5a, and this time this will give me this. Now plus I've taken ab out, but now I have b squared here, so I'll bring b over here. This time this will give me this, this time this will give me that. Now let's see the fourth one. 3xy squared minus 6xy. Clearly 3 is a common factor, so 3 is coming out. I can see x, I can see x here, so x is coming out. But I can see y squared here, y here, so y is coming out. But then here I'll get y, so that this time this will give me the 3y squared. Then here I have 6, so that'll be 2. 3 times 2 will be 6, and then xy, yes, so I have been able to factorize out. Now let's see, we have 7x to the power 7 minus 14x to the power 14. Now let's see, we can see that 7 is common, so 7 would come out. Now here we have x to the power 7, we have x to the power 14, so clearly x to the power 7 can come out. What is remaining here? 1. This time this will give me this. Now 7 times what will give us 14, so 7 times 2 will give us 14. But in the numerator, we know that when the bases are the same and we are multiplying, we add. So here becomes x to the power 7. So 7 times 2, that's 14. And then 7 plus 7, that would also be 14. Now let's see this. We say we factorize the following. And then the first question, we have x plus 1 minus 2x plus 1. Make sure that you subscribe if you've not done that. We have a whole lot of videos that will help you pass your exams with ease. Now clearly, what can we see? X plus 1 is common, so we can bring the x plus 1 out. X plus 1 is here, x plus 1 is here. We'll bring it out, and then we have x minus 2. Now you should note, if you have ab plus ac, the common one is a out. We have b plus c. In this case, x plus 1 is common. We bring it out, bring the a out, and what is left here? X minus 2. Now let's see question number 2. We have 3x 1 minus x plus 2 1 minus x. Now with this, what is common? You can see 1 minus x, 1 minus x common. Bring the 1 minus x out. 1 minus x out. What is left here? We have 3x plus 2. Now let's see question number 3. Question number 3, we have m plus n. And then we have 2x minus y minus x. We have m plus n. Now what can we see? M plus n common. Bringing it out, so we have m plus n out like this. Now what is left? 2x, so we have 2x minus y minus x. Y, let's see, a, b, a, c. The common one is a. Bringing the a out, what is left here? B, what's left here? C. The same way here, m plus n common. I'll bring it out. What is left? 2x minus y minus x. Am I done? No, I'm not done. Let's see, 2x minus x. That is x, so we have m plus n. 2x minus x, we have x minus y. Now, let's see the fourth question. The fourth question, we have m, 2a minus b minus 2n. We have b minus 2a. Now, let's see here. we have 2a minus b, but in this case, we have b minus 2a. Now let's note this. Let's note, if we have a minus b, we can factorize negative out. So if you factor negative 1 out, you see the negative will not affect the a. So you have negative a, and then this becomes positive, so you have plus b, and we can express this as that is b minus a. Again, if you have a minus b, we can factorize the negative out, and when the negative come out, the negative will not affect the a, so you have negative a plus b. Now negative times negative, positive, negative and positive, negative, and we can rewrite it as b minus a. Hence, so with this we have our m 2a minus b minus 2 and b minus 2a. Now we have m, we have 2a minus b. Now this and this, we can see that clearly we have 2a minus this, so we can factorize negative out, and we have negative 1, we have negative, so I will factorize the negative 1 out, and I'll get 2n, that is 2a minus b. This negative 1, that is a negative 1 over here, and then I'll interchange, so I'll get 2a minus b. Now negative and negative will give me positive, so I have m 2a minus b. We have plus 2n 2a minus b. Clearly 2a minus b is common. I can bring it out, and I have 2a minus b. What do I have here? M plus 2n. Now let's see the fifth question. I have x a minus c plus y c minus a. Now let's see a minus c, c minus a. This is not common, so you have to make it the same. So I can factorize negative out here. So I have x a minus c plus, but here I'll factorize the negative 1 out. So here becomes negative y. Here I'll get a minus c. I have a minus c, so that will be a minus c. And then what do I have here? X. What do I have here? Minus y. Now I would like to consider factoring by grouping. And in the first example, we want to factorize the following. That is ax plus ay plus bx plus by. So the first one, we have ax plus ay, bx plus by. Now clearly a is common in the first two, so a out, x plus y. The second two, b is common, so I have b x plus y. So you can see x plus y common. Bring it out, so I have x plus y. And then what is left here? A plus b. Now let's see the second one. We have am minus bm minus an plus bn. Now the first two, there's something that is common. I can see that clearly m is common. So I have my m, I have a minus b. Now, looking at this two, negative n is common. So I'll bring negative out. So I have negative n out. I'll get a minus b. Now, negative times this, that will be negative an. Negative times negative, that's positive. So you have to be very careful when you're factorizing terms like this. Now let's see, a minus b is common. Factorize the a minus b out. And then we have m minus n. Now let's see the third one. We have x squared plus ax minus x minus a. Now with this, let's consider the first two terms. Clearly x is common, so we can bring x out. So we have x plus a. This time this x squared, this time this, that is ax. Negative x, negative a, so you can factorize negative 1 out. So we have x plus a. Now x plus a common, factorize it out. So you have x plus a. What do you have here? X minus 1. Now let's see the fourth question. We have 2xy minus 6 mn minus 3 my plus 4 and x. Now here you can see xy, and then here we can also see that we have 4nx. So let's bring this and that together. So here we have 2xy plus 4nx. And then I have minus 6mn minus 3my. Now what can I see? X is common, S is common, 2 is a factor here, 2 is also a factor here. So I can have 2x out and I have y. Now this is 4nx, so I'll get plus 2n. Now this time this, that'll be 2xy, this time this, that'll be 4nx. Now this and this, clearly m is common and 3 is also common, so you can bring negative 3m out. When m is gone out, what am I going to get? Here I will get 2n because m is already gone. 3m times this, that will give me this. Now here 3m is gone, so I have plus y. This time this will give me that, this time this will give me that. Now we should know that y plus 2n is the same as 2n plus y. So we can rewrite this as 2x y plus 2n minus 3m y plus 2n. Y plus 2n are the same, so we factorize it out. Y plus 2n the same. Now what do I have here? So the remaining here I have 2x minus 3m. That's very easy. This is a past question. Now let's see the fifth one. We have x squared plus x squared y plus 3x minus 10 y plus 3xy minus 10. Now let's see. So you have xy, that is x squared plus x squared y. So this and this, I can factorize it out. Now 3, let me bring this one here. So this one will be x squared plus s squared. Now I'll bring plus 3x plus 3xy because the common one 3x will go out. We have minus 10y minus 10. Now what is common here? I have y here. Now what is common? X squared is common, so x squared out. What do I have? 1 plus y. Now this 2, what is common? 3x, so 3x is common. I have 1 plus y. Now this negative 10 is common. I have y plus 1. Now y plus 1 is the same as 1 plus y. So I have x squared, this 1 plus y plus 3x. We have 1 plus y. Now, and then here we have minus 10. This is also the same thing. I can rewrite it as this 1 plus y. Now, from here, x squared, I can see that 1 plus y, 1 plus y, 1 plus y is common. Bring it out, so I have 1 plus y. Bring it out. What do I have here? I have x squared plus 3x minus 10. This is what I have over here. Now, so I've brought the 1 plus y out. Now, we have a quadratic equation here, and we are yet to do quadratic equation. So I'll leave it. Continue watching. You see how we'll be able to factorize quadratic equation. So that's what we have, but then that's only for the grouping. But then here we are not done. We have to factorize this. But because we've not done quadratic factorization, which will be the next thing that we'll be doing, kindly continue watching the video and you'd enjoy it. Now I'd like to consider factorization of quadratic expression. Now quadratic expression is of the form that is ax squared plus bx plus c, where a, b, and c are constants. Now, and then our a should not be equal to 0. And then to factorize this, we have two cases. Now let's consider case 1. Case 1. Now the case 1 is when a is equal to 1. So when you have a to be equal to 1, our quadratic equation becomes 1x squared plus bx plus c. And this is just equal to x squared plus bx plus c. Now, to factorize x squared plus bx plus c, we need two integers. Let's say we need two integers. We need two integers p and q, such that we need two integers p and q such that when we multiply, that is when we multiply p and q, we are going to get c. We're going to get c, and then when we add p plus q, we are going to get b. When we multiply p and q, we get the c. When we add, that's p plus q, the same factor as p plus q, we are going to get b. Remember, the coefficient of the x squared is 1. Hence, our quadratic equation will now be, that is our x squared plus bx plus c will now be what? X squared plus, now what is our b? Our b is p plus q. So we have p plus q. We have x over here, and then plus our c. Now what is our c? Our c is p times q. Our b, p plus q, our c, p times q. Now this would give us x squared, and then this will give us, that is px plus qx. That is using the distributive law, px, and then we have qx. And here will be pq. Now with this, let's see, let's take two at a time. X squared x, x is common, so you can factorize x out. We have our x plus p. Now let's see, qx, pq, q is common, so when you factorize q out, we are going to get x plus p. Now x plus p common, factorize the x plus p out, you get x plus p out. What is left here? We have our x plus q, which is very, very easy. So as I said, if you have x squared plus bx plus c, you need two integers such that when you multiply, we are going to get a c, and then when you add, we are going to get the b. So if the integers are p and q, then we get p times q is c, p plus q is our b. We substitute and we get this wonderful factorization, which is very, very easy. Now let's continue with some examples. Now let's consider the factorization of the following. Now the first one, we have x squared plus 3x plus 2. Clearly you can see this is case 1, while the x squared, coefficient of the x squared is 1. So we need two numbers. When you multiply, you get 2. When you add, you get 3. And clearly the factors are 1 and 2. While 1 times 2 will give us 1 plus 2, that will give us what? 3. So here, this we are going to get, that is x squared plus x plus 2x, and then plus our 2, because x plus 2x is giving us that 3. So the factors we see 1 and 2. Now from here, x and x is common, so you have x out, x plus 1. This and this 2 is common, you have x plus 1. So x plus 1 is common. You factorize that x plus 1 out, and then what do you have here? X plus 2. Now let's see the second one. We have x squared plus x minus 6. X squared plus x minus 6. Here, two numbers, when you multiply, we are going to get negative 6. But when you add, we are going to get 1. That will be positive 3 and negative 2. So over here, that will be what? X squared plus 3x minus 2x, because the factors are 3 and negative 2. We have minus 6. So with this x squared and 3x, x is common, we bring the x out, we have x plus 3. Now here minus 2, we have x plus 3. So x plus 3 common, we factorize the x plus 3 out. And what do you have here? X minus 2. Now let's see the third one. We have x squared minus 7x minus 18. Now this is case 1. The coefficient of the x squared is 1. So here, 2 numbers, when you multiply, you get the negative 18. This is negative 18. But when you add, we get negative 7. And clearly, that is negative 9 and then 2. Why negative 9 times 2, that's negative 18. Negative 9 plus 2, that's negative 7. So we have x squared minus 9x plus 2x minus 18. So with this, x is common, x out, we have our x minus 9. And here 2 is common, so we have x minus 9. So easy. X minus 9 out, so you have x minus 9 out. And what do you have here? X plus 2. Now, let's see the fourth one. We have a squared minus 2a minus 24. So two numbers, when we multiply, you see this case, one coefficient of the a squared is 1. So when you get negative 24, when you add, you get negative 2. And this clearly, that is negative 6 and positive 4. So we have a squared minus 6a plus 4a minus 24. Now this a is common, so we have a minus 6 plus 4, we have a minus 6. A minus 6 common, factorize it out, a minus 6. What do you have here? A plus 4. Now let's see our fifth one. We have x squared minus 2x minus 35. Two numbers, when you multiply, we get negative 35. When you add, we get negative 2. And that is negative 7 and positive 5. So we have x squared minus 7x plus 5x minus 35. Negative 7 plus 5x, we get negative 2x. When you multiply, that will be 35. So clearly, this will give us x. We have x minus 7 plus 5 out, x minus 7 out. X minus 7 out. Factorize it out. So you have x minus 7 out. What is left here? We have x plus 5. Now let's consider the case 2. Now we know the quadratic equation is we have x squared plus bx plus c, quadratic expression. Now the case 2, that is when if a is not equal to 1, that is any other number apart from 1, then we are going to get our quadratic equation still to be ax squared plus bx plus c. Now we need two integers such that when we multiply, in this case, we need two integers such that when we multiply, so let's suppose that p and q, so if you multiply p times q, you are going to get the ac. You get ac. You multiply the a and then c, you get ac. And then when we add them, we are going to get b. You see, the previous one, we had x squared plus bx plus c. So you say when you multiply, you get c, but when you add, you get b, because this is 1 times c is giving us c. But here, in front of the x squared, we have a, so a times c, that's what ac. So you see when you multiply, you get ac, and then when you add, you get b. Therefore, our a x squared plus bx plus c, this will just be a x squared plus our b. What is our b? That is p plus q. We have x plus our c, and then from here, we factorize from here. Let's consider some nice examples and then solve them. Now let's consider this example. Factorize the following. The first one, that's 2x squared plus 5 x plus 3. Now 2 times 3 will give us 6. So two numbers, when you multiply, you have to get 6, and then when you add, you have to get 5. Clearly 2 times 3. 2 plus 3 with 6, 2 times 3, that will be 6. So here we have 2x squared plus 2x plus 3x plus 3. Now with this, the common factor is 2x. So we have 2x that will be x plus 1. And here 3 is common, x plus 1. You can see x plus 1 common. Bring the x plus 1 out. So what is left? We have 2x plus 3. Now let's see the second question, which is a past question. We have 6x squared minus 5x minus 6. Now here we have to multiply the 6 times negative 6. That will be negative 36. So two numbers when you multiply, you get negative 36. And then when you add, you get negative 5. And that is negative 9 and positive 4. So we have 6x squared minus 9x plus 4x minus 6. Now this 3 is common, so we can factorize 3x out. We have x minus 3. And then, but then here, remember it's 6, so there will be 2 over here, 3 times 2, giving us the 6. Now here, what is common? 2 is common, so 2 out, we have 2x minus 3. 2x minus 3, 2x minus 3, bring the 2x minus 3 out. So you have 2x minus 3. What is left here? We have 3x plus 2. Now somebody's asking, why is the factors negative 9 and then 4? Now 6 times negative 6, that is negative 36. So we look for the factors of that negative 36, which is plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4. We have plus or minus 9, plus or minus, that will be 12. We have plus or minus 18, and then plus or minus, that is 36 itself. Why? Now 1 times this will give us 36, and then 2 times 18, 36, 3 times 12, 4 times 9. So which of this, when you add, you will get that is negative 5. Clearly the factors will be within this. Yes. So either positive 4, negative 9, yes, don't work. So we have to consider them like that. So that's how we add it. Now let's see the third one. In this case, we have 3 minus 2x minus x squared. In this case, the coefficient of the x squared is negative 1. So negative 1 times 3, that's negative 3. So two numbers when you multiply, we are going to get negative 3. But when you add, we are going to get negative 2. And clearly this is negative 3 and then positive 1. So here we have 3 minus 3x plus x minus x squared. Why negative 3x plus x is giving us that. So from here, what is common? 3 is common, so you have 1 minus x plus x, 1 minus x. You can see 1 minus x common, so we can bring 1 minus x out. Now what do you have here? 3 plus x. Now let's see the fourth question. Let's see the fourth question. We have 35 minus 2b minus b squared. Now, so here we have to multiply the negative 1 times 35. So that will be two numbers. When you multiply, you get negative 35, but when you add, you get negative 2. Now, factors of the 35, you have to consider that. And then in that, we see that the factors will be, that is negative 7 and then positive 5. So negative 7 times positive 5, that will be negative, that negative 7 plus positive 5, that will be negative 2. So we have 35 minus 7b plus 5b minus b squared. Now here, what is common? The common one is 7. So 7 out, we have 5 minus b. Then plus this b is out, b is common, so 5 minus b. So 5 minus b is common. We bring it out, and then we will get 7 plus b. And this is the fourth one. Now let's see the fifth one. So we have, that is x squared plus 4x plus 3 plus mx plus 3m. Now, so from here all the way to here, that is quadratic equation in one variable. So here, two numbers when you multiply, you are going to get 3. When you add, you get 4. That will be 3 and 1. So that will be x squared plus 3x plus x. We have plus our 3. We have our m, x plus 3m. Now this two, what is common? X is common. So we have our x plus 3. Now x plus 3, 1, x plus 3. We have x plus 3, x plus 3. Now we have mx plus 3m, so m is common. We have x plus 3. Now x plus 3, x plus 3, x plus 3 common. Bring it out, so you have our x plus 3 out, common 1. So you have x plus 1 plus m, which is very, very easy. This is a pass question. Now let's consider factorization of quadratic expressions into variables. So the first one given to us, we have 6x squared plus 5xy minus 6y squared. Now this case 2 of the first one, 6 times negative 6, that is negative 36. So 2 numbers when you multiply, you get negative 36. When you add, you get 5xy. Hence, the factors will be, so negative 36 and 5, that will be positive 4. No, that is negative 4, positive 9. So we have 6x squared plus 9xy minus 4xy minus 6y squared, because 9 times negative 4, that's negative 36. 9 minus 4, this will be positive 5. Now this 2, what is common? 3x is common. So you have 2x plus 3y. Now this 2, what is common? Negative 2y is common. So you have 2x plus 3y. So 2x plus 3y, 2x plus 3y common. We factorize it out, so we have 2x plus 3y out. What is remaining? We have 3x minus 2y. Now let's see the second one. Second one, we have 2y squared plus xy minus 3x squared. Now, 2 times negative 3, that will be negative 6. So 2 numbers, when you multiply, you get negative 6. But when you add, we get the middle one. And because it is in 2 variables, that is why we have here xy, xy. The first one, only 1 variable. That's why if it is x, we write in x. If it is y, we write in y. By your 2 variables, we have xy, xy. So 2 numbers, when you multiply, you get negative 6. When you add these 2 numbers, you get 1. And clearly, this will be negative 2 and then positive 3. This time this will give us negative 6. Then negative 2 plus 3, that will be 1. So we have 2y squared. Now xy, so that will be 3xy minus 2xy minus 3x squared. Now let's see what is common. You can see y common here. We can bring the y out, and we have 2y plus 3x. Now let's see here, x common, so we can bring minus x out. What do we have? We have 2y plus 3x. Negative times positive, that's negative. That's what we have here. We You have 2y plus 3x, 2y plus 3x. We can bring that one out. So 2y plus 3x. And then you have y minus x. Now let's consider this example. 2s squared minus 3st minus 2t squared. So you multiply this time this, so that way two numbers, when you multiply, you're going to get negative 4, but when you add, you get negative 3. What do you think will be the factors? When you multiply, you get negative 4, when you add, you get negative 3. That will be negative 4 and 1, and negative 4 plus 1. This will give us negative 3. So we have 2s squared minus, now so we have minus 4st, the variables st plus st minus 2t squared. Now here 2s is common, 2s is also common here. So we have 2s common, s minus 2t plus, now let's see this, what is common? T is common. So we have s minus 2t. Now s minus 2t, s minus 2t common. Factorize it out. S minus 2t. What do you have here? 2s plus t. Now let's see the fourth question. We have x cubed minus 5x squared y plus 6xy squared. Now with this, what is common? X is common throughout, so we factorize x out. Now we have x squared minus 5xy plus 6y squared. And clearly the inner one now becomes quadratic equation in two variables, x and y. Now, so here two numbers, when you multiply, you get 6. When you multiply, you get 6. But when you add, we get negative 5. And clearly that will be negative 3 and negative 2. So we have x squared minus 3xy is two variables, minus 2xy plus 6y squared. We have our x over here. Now x, this 2x is common, we bring x out, so you have x minus 3y. Now let's see, y is common, negative 2, so you bring negative 2 out, 2y out, you will get x minus 3y. Okay, so from here we can see x minus 3y being a common factor, so we have x minus 3y. And then what do you have here? We have x minus 2y. And we can rewrite this as, that is x minus 3y, x minus 2y, but then there's x here, x multiplying everything. Now we consider difference of two squares. And this is what difference of two squares is. If you have a square minus b square, we say this difference of two squares. And this is the same as a minus b, and then we have a plus b. Now let's show that this is equal to this. So if you have a minus b, a plus b. Now we apply the distributive law repeatedly. So we pick the a, multiply, so the a will multiply everything, and then the b would also multiply everything here. So you have a multiplying a plus b. Now negative b, multiply everything here. You have a plus b. Now a times a, that is a squared. A times b, that is ab. Now here negative b, a, so the same as negative ab, and then minus b squared. Here what can we see? ab and ab. We have positive ab, negative ab to cancel out. So this will cancel out this. So you have a squared minus b squared. So all that we are saying is that anytime we see a squared minus b squared, this is just equal to a minus b, and then we have a plus b. Now let's consider the following examples for better understanding. Now let's consider this example. Factorize the following. So the first one, we can see x squared minus 4 squared. Now from the rule, a squared minus b squared is a minus b, a plus b. So this is just x minus 4, x plus 4. The rule says if you have a squared minus b squared, a minus b, a plus b. Now let's see the second one. So we have v squared minus 16. Now, so the rule says if you have a squared minus b squared is a minus b, a plus b. So how can you change this to have a square so that the number remains the same, doesn't change? So here we have v squared, we know 4 squared is the same as 16. That's 4 times 4, 16. And here, using the rule, that is v minus 4, v plus 4. This is very easy. Now let's see the third one. We have t squared minus 49. Now here, so we have our t squared. Now, how do we change 49 in such a way that it doesn't change, the number remains the same thing? So that is what? Minus 7 squared. 7 times 7 is 49. So using the rule, t minus 7, t plus 7. This is very easy. Now let's see the fourth one. If we have k squared minus 121. Now 121, how can you change 121? That is 11 squared. So we have k squared minus 11 squared. And this is just, that is k minus 11. And then we have k plus 11. Now we can also have something like probably k squared minus 1. And 1 can be expressed as 1 squared because 1 times 1 is the same as 1. So you can have k minus 1, k plus 1. We should note that if we have 1 square is the same as 1 because 1 square is the same as 1 times 1, which is 1. Now we can also have v squared minus 1. This is just v squared minus 1 square. 1 square is the same as 1. So here v minus 1, v plus 1. Now we can have w squared minus 1. And this is just w squared minus 1 square because 1 square is the same as 1. We've not changed the question. W minus 1, W plus 1. Very, very easy. Now let's consider this example. Factorize the following. We have 4x squared minus 1. But then before that, let's note this. If we have AB all to the power n, you can see that the A is multiplying the B. We say that A n, B n. And if we have 2x all to the power 2, we say this is 2 square x squared. And this is just 4x squared. And if we have 3t all squared, this is the same as 3 square t squared. Now, from here, what is 3 square? 9. And then here we get t squared. So if you get this, we can see it is this as well. Now, let's come to our solution. Now, the first one, we have 4x squared minus 1. We know the principle is difference of 2 squared, so we should see 2 squared somewhere. Now here, 4, we can change 4 as 2 squared. And then here we have x squared minus 1. We can, 1 squared is the same as 1 because 1 times 1 is 1. Now, from here, we know that if you have a and b n, it's the same as ab all to the power n. So right, we can say that 2x all to the power 2 minus 1. And from here, this is the same as 2x minus 1. We have 2x plus 1. Now let's see the second one. We have 9m squared minus 1. Now you can change 9 as 3. So here we can get 3 squared. We have m squared minus 1 squared. Because why? 1 times 1 is 1. That's why I've changed to 1 squared. Now from here, applying this property, so this is 3m all squared minus 1 squared. And this is just 3m minus 1. We have 3m plus 1. Very, very easy. Now let's see the third one. We have 9 minus 4t squared. Now 9, you can change the 9 as what? That is 3 squared. Now minus 4, we can change 4 to what? 2 squared, and then we have t squared. Remember, we want to get a squared minus b squared. Now, this is the same as, that's 3 squared minus 2t all squared. That is a and b, and this is the same as ab all to the power n. So if you have this, you can say this. So this can be said to be equal to this. So here, that is 3 minus 2t, and then we have 3 plus 2t. Now, let's see the fourth one. We have a squared minus 9b squared. Now, here, so we have our a squared minus the 9. We can change 9 to 3 squared b squared. And then we apply this property, which is so powerful in difference of two squares. Here we have 3b all squared. And from here, we'll be getting, that is a minus 3b, and then a plus 3b. Now let's consider the fifth. Now this is the fourth one. So I've rather interchanged it. So this should be our fifth one. Now our fourth one was rather 4a squared minus 16. And this is just, we can change the 4 to 2 squared. A squared minus 4. 16 can be expressed as 4 squared. Now we have, this is the same as 2a all squared minus 4 squared from the property over there. Now this difference of 2 squares. So here 2a minus 4, and then we have 2a plus 4, applying difference of 2 squares. Very, very easy. Or here, now, but then here too, if we are factorizing completely, we have to take note of this. Let's see, 4a squared minus 16. Now this we can factorize 4 out. We have 4. We have a squared, and then here we can get 4 because 4 times 4 is 16. So we have 4. We have a squared minus 2 squared. 2 squared. Now this is the same as, that is a minus 2, a plus 2. Now here we can see that we can factorize 2 out from here. We can also factorize 2 out from here. What I'm saying is that here we have 2a minus 2. And then 2 out of here we have a plus 2. So this times this, that is 4a minus 2a plus 2. That is all that I'm saying, which is the same as this very one. Now let's see the vein I. We have 1 over 16 minus 18t, that is 81t squared. Now with this, before that, let's note this. If you have a over b all to the power n, this is a to the power n all over b to the power n. Now hence this, we can change this as 1 over 4 squared. We want to see squared. Now 81, how can you change to square? So that is 9 squared, and then we have t squared. And this, from this law, if you have a over b all to the power, it's the same as a and bn. Now this is the same as, you can see that 1 to the power 2, 4 to the power 2 minus 9 squared t squared. And this is the same as 1 over 4 all squared. Because we have a and b, and here have 1 square, 4 square, we can change as this, minus 9t all squared. So now we have difference of 2 squares, and this is just 1 over 4 minus 9t, and then we have 1 over 4 plus 9t. Very, very easy. Now let's consider this example. Factorize the following completely. The first one, we have 36p squared minus 49q squared. Now 36, we can change 36 as 6 squared. So 6 squared p squared minus, here 49, that is 7 squared q squared. So applying the property, that is, if you have a, b, or n equal to a and b, n, here will be 6p all squared minus 7q all squared, applying that property. So from here, that is 6p minus 7q, and then we have 6p plus 7q. Now, let's see the second one. We have 9x squared minus 25y squared. Now you can change 9 to 3 square x squared. 25 you can change 5 square 1 y squared. So you have 3x all square minus 5y all square. And here difference of two squares, 3x minus 5y, 3x plus 5y from the root difference of two squares. Now let's see the third one. We have 16x squared minus 9y squared. Now 16, we can change 16 as 4 square. We have x squared minus 3 square y squared. And this is just 4x all square minus 3y all square, difference of two squares. So that's 4x minus 3y, 4x plus 3y. Now let's see the fourth and final one. We have 9a squared t squared minus 1. And this is just, we can say this is just 3 square a squared t squared minus 1 squared. Now we know if it is a, b, all to the power n is a and b n. And it's the same as if you have a, b, c, all to the power n, that will be a to the power n, b to the power n, c to the power n. So here, this is just 3at all square minus 1 square. And this is just 3at minus 1, 3at plus 1. Very, very simple and interesting. Now let's consider this example. Factorize the following completely. So we have our first one, that is 50 minus 2y squared. What is common? You can see that here we can express this as 25 times 2, 2 times that. So 2 is common, 2, so we even get 25 minus y squared. Now, we cannot change this to difference of two squares, so we have to change the 25. So we have 5 squared minus y squared. And this is just, we have 5 minus y, 5 plus y. Now let's see the second one, that is 3x squared minus 48y squared. Clearly, what is common? 3 is common. So we factorize 3 out. We will get x squared minus 16y squared. Because 3 times 16 will give us 48. Now, this is just, we have x squared, and this we just change for y all squared. And the inner one, we have difference of two squares. So you have 3x minus 4y, and then we have x plus 4y. Very, very easy and interesting. Now let's see the third one. We have, the third one is 3x to the power 3 minus 12x. Now here, what is common? Clearly, 3 is a factor here, 3 is also a factor here. So 3x is a factor. So you have 3x out, and what are we going to get? X squared minus 4. And this is just 3x. Here is x squared minus 2 squared. So we have 3x, we have x minus 2, x plus 2. Now, let's see the fourth question. The fourth question, we have 18p squared minus 2. 2 is a factor of this, 2 is a factor of that. So we can factorize 2 out. What are we going to get? 9p squared minus 1. And here we have 2. This is 3 squared p squared minus 1. And we have 2. We have 3p all squared minus 1 squared. And this is just 2 out. We have 3p minus 1. 3p plus 1. Very, very easy. Now let's see, we have 32x to the power 3 minus 8xy squared. Now, 8 and 32, 8 is a factor of here, 8 is also a factor over there, so we can bring 8 out. And then what again, we can see that there's x here, there's x there, so we can bring x out. And what are we going to get? 4x squared, because 4 times 8 is 32, and then x, we have 1 plus 2, that's 3. So minus y squared. Now we have our 8x here. We can change this to 2x all squared minus y squared. And here we have our 8x out. We have 2x minus y, 2x plus y. Very, very easy. If you've not subscribed, make sure that you do that and get a copy of the books that you are seeing on the screen. It will give you a very good foundation in mathematics. Okay, let's consider this example. We have 4p squared q minus 25q to the power 3. So we have 4p squared q, 25q all to the power 3. And with this, now we can see that q is common, so we can factorize q out. So q out, what do you have now? 4p squared minus 25q squared. Pivot it to the power 3. Now q1 is out, so I'll get that is 2. Now I can change this now difference of 2 squared. So I have q outside. Now 2p, I'll get 2p all squared minus 5q all squared. So now I have difference of 2 squares. So here I have q, 2p minus 5q, 2p plus 5q. This is my A, and then this is my B. Now let's see the second question. You have 27p squared x squared minus 48y squared. Now with this, what is a common factor? Clearly 3 is a common factor of them. Yes, only 3. So when I bring 3 out, I'll be getting 9p squared x squared minus 16y squared. 3 times 9 is 27, 3 times 16, that is 48. And this is just, I can change all this, so I have 3px all squared minus 4y all squared, applying the principle we learned earlier on. So you have 3px minus 4y, and then you have 3px plus 4y. This is very, very easy. Please. Now let's see the fourth one. We have x minus 3 all square minus y square. So this is our A, and then this is our B. Don't be confused. We have A square, and this we say A minus B, A plus B. In this case, our A is x minus 3. So that will be what? A, so this is our A minus B, and then A plus B. Our A now, this is our A, this is our B, so A minus B, A plus B. And here, what can I do about it? There's nothing I can do about it. Probably I just write x minus y minus 3, and then here, that will be x plus y minus 3. That is all. Now let's see the fifth one. We have 5x minus 2 all square. We have 4y plus 3 all square. So this is our A, and then this is our B. So here, that will be A minus B. So our A is 5x minus 2. But minus B, but this B is 2 times, so I have to put it in bracket. 4y plus 3, because the negative is affecting everything. So this is our A minus B. And then A plus B, 5x, the question, that is negative 2 plus B. So let's put this 2 in bracket, this in bracket, and then 4y plus 3. Now, this will give us 5x minus 2 minus 4y, and then minus 3. That's why we brought the 2 brackets, negative and positive, that's negative. And here we have 5x minus 2 plus 4y plus 3. Now 5x minus 4, so we have 5x minus 4y. Now negative 2, negative 3, we can put them together, negative 5. Now we have 5x plus 4y, negative 2 plus 3, and that is just 1. Now let's consider the following example. Factorize the following completely. Now we have a squared minus a minus b all square. Now, so this we know a minus b plus, so these are a, and then this, the whole of this is our b. So that is a minus b. And because this is 2 terms, that is why I have the bracket over there. And then I have a plus a minus b. Now, the negative will multiply through, so you have negative a plus b, negative, negative, positive. And then here we have a plus a minus b, positive, this, positive, and the negative. Now a minus a, so the a will go away, we have b. Now a plus a, we have 2a minus b. Now let's see the second one. We have x plus x all square minus 36x all square. Now here we can express this as x plus 6 all square minus 6 square x square. And from our previous idea, we have x plus 6, and this will be minus 6x all square. And this is just x plus 6 minus 6x. We have x plus 6 plus 6x. Now, x minus 6x, that's negative 5. So I can write the 6 first, 6 minus 5x, x minus 6x, giving us the negative 5x. Now, x plus 6x, that is 7x plus 6. Now, let's consider the next example. That is the third one. This past question. So we have 9a squared minus 4a minus b all square. Now you can change the 9 square as we can change this as 3 square a square minus 4. You can change as 2 square a minus b all square. Now from the property that we learned, that if you have ab all to the power n, this is a n b n, we apply it over here. So we have 3a all square minus 2a minus b all square. Applying, so over here you can see that the n is 2, the same thing, 2. So you can express it as that. Now from here, this is the same as 3a minus 2, we have a minus b. So this a minus b, a plus b. So 3a plus we have 2a minus b. This is what we have. So from here, this is giving us 3a. This time this negative 2a, later negative positive, so you have positive 2b. That's the first one. Now let's see the second one. We have 3a, this time this 2a minus 2b. Now let's see, 3a minus 2a, and this is just a. And what do you have? 2b. Now let's see here, 3a plus 2a, this is just 5a minus 2b. Now let's see the fourth one, which is also a past question. M squared minus 2mn plus n squared minus 9r squared. Now from here all the way to this place, that is quadratic expression into variables. So over here, two numbers, when you multiply, we get 1. When you add, we get negative 2, and that will be negative 1, negative 1. So here that becomes m squared minus mn plus n squared minus 9r squared. If you have forgotten, kindly go back to the video and watch the other one, how to factorize quadratic equation into variables. Now here m and m is common, so we can factorize m out. So we have m minus n. And then here we have n. So negative n, because of the negative here, negative will come out. What do you have? Leaving m minus n minus 9r squared. This time this will give us a negative, negative, positive, and we are going to get this. Now from here, what can we see? M minus n is common, so we can bring that one out. So we have m minus n out. What do we have here? We have m minus n out, which is a, what do you have here? M minus n minus 9r squared. Now let's say from here, m minus n, the bases are the same. This to the power 1, this to the power 1. So this is just m minus n all to the power to y 1 plus 1, which is equal to 2. A times a is a squared. So m minus n times m minus n, that is m minus n all squared. So minus 9r squared. What can we see? A difference of two squares. We can change this. So we have m minus n all squared minus, this is the same as 3r all squared. 3 squared r squared, then we can change as this. So from here we have m minus n minus 3r. You have m minus n plus 3r. And over here there's nothing for us to do. But then when you look over here, because we have the a and then a, we have to simplify. But over there there's nothing for us to simplify. I believe you've enjoyed the lesson. Very, very interesting lesson. Don't forget to subscribe and let your friends also know about this wonderful page. Now let's consider this example, and we have the first one. We factor the following. We have 49 x squared y squared minus 1, 44 a squared b squared. Now this difference of two squares, we can change 49 to 7 squared. We have x squared y squared. Now 144 we can change to what? 12 squared a squared. We have b squared. And from here, this is the same as 7xy all squared minus 12ab all squared. So difference of two squares. This is just 7xy minus 12ab. 7xy plus 12ab. Now let's see the second one. We have x plus y minus 1 all square minus, we have x minus y plus 1 all square. So this difference of two squares, this are a and this are b. A minus b, a plus b, so this minus this. So the first one, x plus y minus 1, a minus b. And I'm putting it in bracket because it's more than one term. And then we have x plus y minus 1 plus x minus y plus 1. So a minus b, a plus b. Now, from here we have x plus y minus 1. Now this negative is affecting everything here. So that will be negative x, negative and negative, positive y, negative and positive, negative 1. And then from here we have x plus y minus 1, and this will be plus x minus y plus 1, multiplying the 1 through. Now what can we see? We can see that clearly x and x will go away, y plus y, so we have 2y. Now negative 1 minus 1, that's minus 2. Now let's see over here, x and x, that will give us 2x, that will give us 2x. And then y minus y, that will go away, negative 1 and then 1, that would also go away. We are going to factorize completely. Now here you can see there's 2 here, 2 being common. So here we can bring 2 here, y minus 1. This time this, 2y, this time this, that. And then here too, we can bring, here we have already 2x. Now let's see, 2 times 2, that's 4. So you can have 4xy minus 1. And this, we have factorized it completely. Now let's see the third one. We have m squared n minus 16 n to the power 5. Now with this, let's see what is common. We have n to the power 5. We can take away 1. So here we can get n out, m squared. We can have minus 16. Now it was n to the power 5. We've taken 1. That will be n to the power 4. And here we can apply difference of two squares. We can get some squares here. So we have n, we have m square. Now 16 is 4 square. And we can change this as n square all square. Now why this? Because there's a property which says that if you have am all to the power n, this is equal to am n. So if I have x square all to the power 2 is x to the power 2 times 2, which is x to the power 4. And if I have a to the power 3 all 2, that is a3 times 2. And 3 times 2, that will be 6. So applying that, so we can see that our n, now we can have m square minus here will be 4n square all square. And from here, this is ab all to the power a and bn. And here we have difference of two squares. We have m minus 4n square or m plus 4n square. This is our a, this is our b. A minus b, a plus b. Very, very interesting. Now let's see the fourth one. The fourth one, we have x squared minus y squared plus 6yz minus 9z squared. Now, from here all the way to here, we can see that we can get that is quadratic expression in two variables. So now let me factorize negative out. So I get y squared minus 6yz plus 9z squared. Now this time this will give us positive times negative times positive, that will be negative. So from here we have our x squared minus, now we have to factorize this. Two numbers when you multiply you get 9, when you add we get negative 6. That is negative 3 and a negative 3. So we have y squared minus 3y, 3yz, remember two variables, yz minus 3yz plus 9z squared. If you've not subscribed, make sure that you do that. Now from here we have x squared minus, okay, so here this and this y out, and then we have y minus 3z. This and this negative z out. And then here, but we also have 3 and 9. 3 is also common, so 3z, and what can we get? Y minus 3z. This time this will give us, this time this, later negative, that will be positive. Now, what can we see? So we have x squared minus, now, y minus z common, bring out that one, y minus z. What do you have here? Y. Now that is, let's see, y minus 3z, y minus 3z. So this is y minus 3z. And you can see y minus 3z, y minus 3z common. Bring it out. What do you have here? Y minus 3z. We have x squared. Now let's see, y minus 3z times y minus 3z. This is the same as this. We are multiplying. In this, if you have a times a, we say a squared. This is the same as this. So we just have minus y minus 3z all squared. And this difference of two squares. That is very interesting. So that will be x minus y minus 3z. And then we have x plus y minus 3z. Very interesting. Now here we have x minus y plus 3z, negative and negative, positive. And then we have x plus y minus 3z. Now, what again can we do about it? No, there's nothing that we can do about it. So we leave it over here. I believe you're enjoying the lesson. Make sure that you subscribe. And I've seen the books too that you see on the screen. Make sure you get a copy of them. They will give you a good foundation. It is having a whole lot of questions that when you work them, you become very, very good. Now let's consider the fifth one. So we have n squared minus 2mn plus n squared minus 9r. Now from here all the way to this side is quadratic expression into variables. From here all the way to there is quadratic expression into variables. So two numbers, when you multiply, we'll get 1, but when you add, we get negative 2mn. So that was negative 1, negative 1. So we have m squared minus mn plus n squared minus 9r. Now, this, we have m common, so m minus n. And then this two, we can see negative n common. We have m minus n minus 9r. Now, m minus n common, we factorize the m minus n out. And then we have m minus n. This and this common. We have this here, we have this over there, minus 9r. Now, m minus n times m minus n, that is m minus n all square. So we have m minus n all square minus 9r. And we can change this as difference of two squares. Now, look at something. We can express this as m minus n all square. And we can change 9 as 3 square. Now, how can we change r as square? If we have square root of r all square, because this square can cancel the square root, and then we have r over there. Now from here we have m minus n all square minus 3 root r all square, and this is m minus n, so that will be a minus b, and then a plus b. So this is the same as m minus n minus 3 root r, m minus n plus 3 root r. And this is a past question of deck 2006. Now let's consider this example. The first one says that we should factorize a square minus b square. So we have our first one, 1a. We have a square minus b square, and that's difference of two squares. So that's a minus b, a plus b. Now let's see the b. The b says that hence or otherwise, simplify fully, that is x squared plus 4 square minus x squared minus 2 all square. So that's difference of two squares. So over here, we have x squared plus 4 all square minus, we have x squared minus 2 all square. And from here, applying difference of two squares, so this a minus b, a plus b. So we have x squared plus 4 minus x squared minus 2. So this is a minus b, and then we have x squared plus 4, x squared plus 4, and then plus x squared minus 2, x squared minus 2. Now, from here, what can we see? So we have x squared plus 4 minus x squared, negative and negative, that's positive 2. And then here, what do you have? We have x squared plus 4 plus x squared minus 2. Now, this is so important. Please note this. I'm bringing bracket here because this is 2 times. So that is why 2 times, so I have to bring the negative, because the negative is affecting everything in it. You have to note that. Now, x squared minus x squared, it will go away. 4 plus 2, that is 6. Now, let's say this. X squared plus x squared, this is just 2x squared. X squared plus x squared, 2x squared. 4 minus 2, that is 2. Now, the question says that we should simplify fully. Now, here, we can see that 2 is common. We can factorize 2 out, or probably we can expand. We can expand because we want to simplify 6 times 2, so we can have 2, that is 12x squared. Why 12? 6 times 2, 12. 6 times 2 again, so we have 12. Very, very easy. So we've been able to simplify. Now, question number 2 says that we should prove 2n plus 3 all square minus 2n minus 3 all square is a multiple of 8 for all positive integer values of n. And here we can see difference of 2 squares over here. So now let's see, we have 2n plus 3 all square minus we have 2n minus 3 all square. And this is difference of 2 squares. So a minus b, a plus b. So here we have 2n plus 3, a minus b, and then we have a plus b. Plus b, so plus we have 2n minus 3. So a minus b, a plus b. Now, from here, the negative is affecting everything on the right hand side. So here we have 2n plus 3. Negative and negative, we have minus 2, and negative and negative, we have plus. Negative and positive, that's what we had, the negative. Now here we have 2n plus 3 plus 2n minus 3. Positive times positive, positive, positive times negative, we have negative. Now, let's see from here. We can see that 2n will cancel the 2n, so 3 plus 3, that is 6. Now, let's see over here. From here, we can see that this 3 and that 3 will go away. 2n plus 2n, that is 4n. Now, 4n, what is 6 times 4n? This is the same as, that is 24n. Now, the question says that we should show that it's a multiple of 8. That is 8 times something. Multiples of 8. 8 times something. Now, we can come out with 8. We can bring a factor of 8 out over here. So that is what? If we bring 8 out, 8 times 4 will give us 24. 8 times 3 will give us 24. Now, so from here, clearly says that, prove that this is a multiple of 8 for all positive integer of n. So clearly for all values of n, this would be a multiple of 8. That is, this would be a multiple of 8. Now when n is 1, 3 times 8 does that. When n is 2, 6 times 8 is still a multiple of 8. So we have been able to show that this is a multiple of 8 for all positive. So for all positive, that is for all and a member of, that is z plus. So this is a multiple of 8. Now let's see the third question. It says we show that n plus 3 all square minus n minus 3 all square is an even number for all positive integer values of n. So we have n plus 3 all square minus n minus 3 all square. So this is question 3. This this difference of 2 squares. So a minus b. So that is n plus 3 minus n minus 3. And then n plus 3. So we have n plus 3 plus we have n minus 3. Now from here, what can we see? We have n plus 3. This time that's negative and later negative, positive 3. And then here we have n plus 3 plus n minus 3. Now what can we see? This and this will cancel. 3 plus 3, that is 6. Now let's see here. This and this will cancel. N plus n, that is 2n. 6 times n, that is 12n. Now, the question is that we should show that this is an even number for all positive integer values of n. Now, for an even number, any even number can be expressed as 2n. Any even number can be expressed as 2n, where n is a member of an integer. But here, they are saying that it should be what? Positive integer. Now, we can express this as, we can bring 2 out. We have 6n. And clearly, we have expressed that this is an even number. So an even number, any number that is multiplied by 2. So for all positive integer, but in this case, they are saying positive integer. So we can express as this, where n is a member of z plus, and this is an even integer. Now let's consider this example. All these questions are past questions. Now, the first one, we are being given 3q plus 13 square equal to 16 square, and then we are being told to find the value of q. I can see square is square. Now let me group like terms, so I'll get 3q equal to 16 square minus 13 square. What do I have here? Difference of two squares. So I have my 3q, and this will be just 16 minus 13, and then here I'll get 16 plus, that is 13. Now, what do I have? From here, 16 minus 13, that is just 3. 16 plus 13, and this is just 29. I want to find q, so I divide through by what is multiplying the q, which is 3. So you have 3q over 3 equal to 3 times 29 all over 3. This is cancelling out that. This also cancel out that. So hence we have q to be equal to 29, which is very, very easy. Now let's see the second question. Let's see the second question. Now, question 2, we have 5r squared plus 22.55 all square equal to, we have 27.45 all square. Now let this go here. So we have 5r squared equal to 27.45 square minus 22.55 square. And here what can we see? The difference of two squares. So we have 5r squared. So you have 27.45 minus 22.55. And then here, what do you have? 27 plus 4, 5 plus 22.55. Now here will give us 5r squared. Now let's see, what is 27.45 minus 22.55? And this is just 4.9. Now, what is 27.45 plus 22.55? This is very easy. This multiplying, but then this will give us 50. We want to find r, so we divide both sides. We have 5r squared all over 5 equal to 4.9 times 50 all over 5. Now this is cancelling out that. 5 will go here 1, 5 will go into 50, that is 10. So we have r squared. Now 4.9 times 10, and this is just 49. Square will go and change to square root, so r equal to square root of 49. And this is just plus or minus 7. Don't forget, anytime you take square root, that is plus or minus. So square root of 49, that is plus or minus 7. Now let's see the third one, which is also a past question. We have 3.46 all square minus 1.54 all square equal to 10x. Now this is difference of two squares. So this is just 3.46 minus 1.54. And then here, 3.46 minus 1.54. So we have 3.46 plus 1.54. A minus B, A plus B. And this is equal to 10x. Now, 3.46 minus 1.54 over here, this is just 1.92. Now, 3.46 plus 1.54, this is just giving us 5 equal to 10x. Now, 1.92 times 5, and this is just 9.6. Equal to 10x. We want to find x, we divide both sides by what is multiplying it. 10 equal to 10x all over 10. This is cancelling out that. So we have our x to be equal to 9.6 all over 10, which will be 0.96. Now we'll consider sum and difference of two cubes. So if we have a to the power 3 plus b to the power 3. Now this can be factorized into, we have a plus b, And then we have a square minus ab plus b square. And if you have a cube minus b cube, now this is a minus b. And then the second we have a square plus ab plus b square. So if it is plus, here becomes plus and this is negative. Please note there's no 2 here. There's no 2 here, here 2, there's no 2 here. And if this minus, and then the second one becomes positive. Now let's consider some examples. Okay, so let's consider the first example. You factorize the following completely. X cubed plus 1. So over here we have s cubed plus 1, and we can rewrite this as s cubed plus 1 to the power 3. Now 1 to the power 3 is the same as what? 1. Now we know that if it is a cubed plus b cubed, it can be factored into a plus b, and then here we have what? A squared plus ab. Now here will be minus plus b squared. So this can be factored into, that is s plus 1. And then here what do you get? X minus ab, so that is x times 1 and then plus 1 squared. You shouldn't forget this is what? X squared. Look at it, a squared, so x squared. So over here we have x plus 1, and this is just x squared minus x plus 1. 1 squared is the same as what? 1. Now let's see the second one. We have y cubed minus 1. Y cubed minus 1. Now if it is a cubed minus b cubed, is the same as what? A minus b. Here becomes a squared plus ab plus b squared. So this is the same as what? Y cubed minus 1 to the power 3. 1 to the power 3 is the same as what? 1. So here this becomes y minus 1. And then here we have what? A squared, which is y squared, plus aby times 1 plus 1 squared. And this is just y minus 1, y squared plus y plus 1. Now let's see the third one. The third one we have 8s cubed minus 27y cubed. Now 8, how can we change 8 to have a power of 3? Yes. So we have 2 to the power of 3, x to the power of 3. Now 27, we can change it to 3 to the power of 3, y to the power of 3. Now we know that if you have ab all to the power n, this an, bn. So if you have this, we can change it into this. So from here, this is the same as 2x all to the power 3 minus 3y all to the power 3. So difference of 2 cubes. So this is just 2x minus 3y, a minus b. And then the other one is what? A squared plus ab. So that is 2x times 3y. Then plus b squared, 3y all squared. So from here we have 2x minus 3y. And this becomes what? 4x squared. 2 times 3, 6xy. And what do you have here? Plus 9y squared. Very, very easy and interesting. If you've not subscribed, make sure you do that. And you see the books that you're seeing on the screen, make sure you get a copy for yourself. It will give you a firm foundation in maths. Now let's consider the fourth one. So that is 2x cubed plus 16. Now how can you do this? There's no way you can change 2 for it to be a power of 3. But we can twist a factor here. Twist is a factor. We can factorize the 2 out. So 2, we are going to get x to the power 3 plus 8. 2 times 8 is giving us the 16. Now 8, we can change our 8. Now 2 to the power 3 is the same as 8. Now from here, factorizing this, that would be what? X plus 2. And then we have x squared minus, we have a times b plus b squared. And here we have our 2 here, x plus 2. And this is just x squared minus 2x plus 4. Very, very easy. Now let's see the fifth one, the very last example. If you know you've not subscribed, kindly do that. A whole lot of videos to help you. You see the books too. Make sure you get a copy for yourself. The very last example, we have 3x cubed minus 81y cubed. Now there's no way you can change 3 for it to be a power of 3. So hence we have to factorize 3 out. So when you factorize 3 out, you're going to get x cubed. Now 3 times 4 will give us 81. 3 times 27. So we have 27y cubed. Now this is the same as we have 3x cubed minus 3 cubed y cubed. And this is the same as we have we have x cubed minus 3y all cubed. Now this is the difference of 2 cubes. So we have equal to 3 here. So we have x minus 3y. This minus this, and then we have a squared plus a times b. These are a, these are b. Then plus b squared. That is very, very interesting and very easy. So we have our 3. We have x minus 3y. Now here a squared, so x squared plus 3xy. And then this is just giving us 9y squared. Now this brings us to the end of our second lesson. Very, very interesting algebraic expression. It forms the foundation in mathematics. Factorization, that's what we've done. Now you should go back, make sure that you are very strong in it, and with that you'll be able to do very well in maths. Don't forget, no pain, no gain. You have to sit down, solve questions on your own. You see the books you are seeing on the screen? Get a copy for yourselves and sit down and solve more questions. And you'll be able to answer any kind of question that is put to you. Don't forget, the heights reached and kept by great men were not attained by sudden flight, but they, while their companions were sleeping, they were toiling upwards in the night. If today I'm enjoying it, it's because I have sat down and then I've solved more questions, understand the principles. In the same way, if you do that, you would also understand it very, very well. Bye-bye.